Uh, in the lecture in lesson 11 for the CCENT, ICND 1, also known as the ICND 100-105. So what we're going to be looking at is the basic switch functions and features. So we're going to talk about a few of the command lines, kind of how to plug into one, how to configure one, and so on from there. And to be honest, guys, I would say from the ICND1, switches is probably the most covered of anything else, knowing the command lines, how to kind of troubleshoot, what to expect. There's a little bit in the routers, but the switches and routers basic functions and how to kind of look for the main stuff is very big in between the two. So, luckily I have a 2950 over here that isn't racked. That I will show you guys over here. We can see it right here. It's actually on the side of my desk. Let's back it up just a little bit. You can see the lights on it, but this is a 2950. Oh, try not to spill my cup here. It would be bad. And this doesn't focus very well, but that is a Catalyst 2950, and the lighting isn't the best in this room. So we're going to be looking at the basic functions here. This is a cord actually to my PC, but for the time being we will go ahead and unplug it. I have two Ethernet adapters or NIC cards on my PC. So as we see, it is actually on, and I'm going to kind of show you the back of it. So this, if you watched my lesson or lecture 2, I talk about the lab setup, and this is one of the switches that I recommended. They're cheap, they're enterprise switches. They do everything that the bigger switches do pretty much, and you can learn everything you need to know for your CCNA with these switches, to be honest. So without further ado, let's kind of, instead of me having to lift them up in the camera, that's why I got the second camera. So if we look back here, right here is my console port. I'm going to show you guys what this actually looks like. If you look there, it looks like an Ethernet in there. In this console port, you can see it says console in like a light blue, which Cisco seems to love to put light blue for the console. And it's quick to notice. That's what I love about it. You get used to looking for it. And then we see over here, that's a regular power cable. Notice there ain't no kind of switch to turn this off, so you have to use a power strip or just unplug it, or you go through the command line and do the reload command. But that's pretty much it. As you can see, switch isn't, that's about, there's my hand, kind of give you an idea how big it is from there. So I mean, it's a good size. It is a, what is it, a 24 port switch, 8 ports in each row here. They make them bigger than that for these 2950, but this is a basic layer 2 switch that is very popular for labs because it does everything you basically need it to. So what you need to understand is that a switch is, as I said, a layer 2. They do make layer 3 switches, but these are layer 2 switches. So what does that mean? We're going to talk more in depth, but switches, layer 2 switches work strictly off of MAC address and using what they call a MAC address table. But what I'm going to do is actually I'm going to unplug the power cable on the very back. So I just unplugged it. You see the lights go off, and so we're going to plug it up, and I want you guys to kind of see what it looks like when it's booting up. That way you can get a general idea. They won't really talk much about the booting up process of a switch really in the CCNA or the ICND1. I'm sorry. All you need to know is what does it do when it boots up. It goes through a post test basically, and basically it runs or decompresses the image or the IOS of the switch. So it looks like it's off, but it's not. It's running. It'll come back up and you'll see some lights. There we go. Here we would hold the mode button if we wanted to basically do a password recovery on the switch, most Cisco switches, and you'll hold it down for throughout the boot process for a little while, and then it would come through and be different from there. See, all the lights are amber. It's booting up. We heard something ding, but that's my, to be honest, that was my putty, but we're going to talk about that. We're not going to worry much about the putty at this point. What we're going to do is say that that's what it was, and we're fixing to talk about how putty works so you guys can learn from the basics. So okay, got that off. So the switch is totally booted up at this point. So I'm going to X out PuTTY, and I'm going to show you guys step by step. But anyways, the console cable was the one that looked like Ethernet. This is the end of that cable, and I will actually take it apart for you guys if I can do it without it sliding everywhere. This thing, and that camera just ain't gonna sit still at this angle. Let's see if I can use the switch to help. There we go. So I'm just gonna take this apart right quick and show you the end of it. It would be this end, and usually computers will have a serial cable in the back. So this is what it looks like, and that's a female end with some pins. I think it's 9 to be exact. But the back of your computer might have something similar to this. And if you do, you don't need this adapter. But basically this plugs in the back of your computer that has a port like this, which is what they call a COM connection, or serial. I'm going to just tighten that back up, and I'm going to show you where this other end goes, so that way you guys know exactly how everything kind of hooks up. Up, tighten, 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 tighten. There we go. So I use it so much I don't want to. Alright, so if we follow this gray line on my desk, you'll see that there's a gray line right there, and it's basically just a USB. That's all it is. It's a USB converter to make my USB into a COM port. So okay, let's switch screens here for a minute, and we're going to have a few things up here. Alright, let's going over to monitor 1. As you can see, we got this. I'm going to need that, and we're going to bring up PuTTY, which should be on my desktop. There it is. So we're going to bring up PuTTY here. It's a serial connection. PuTTY's a free program, by the way. So we got a serial connection, and I know it's on COM3. Now, how to determine if it's which COM it is, especially with a USB adapter, I'd go to Device Manager on the PC, and I can come over here to COM, and I can tell mine's a prolific USB to serial COM port, and in parentheses it says COM3. And then we're going to hit Open with the default settings. Leave your bits to 9600, as you see to the right. That is the default that is used by most everything standard. Some people tweak, or maybe a switch allows more bits in and out for I guess a little bit quicker exchange of information between the COM port, but usually it's not needed. So I use default. So here's the trick. Anytime you go into a COM port, if your switch is already booted up, it's going to look like you got nothing going, right? In reality, it's right there. Just hit enter, spacebar, either or. In this case. So okay, what we're going to do, you can see the switch over here. It is on. I want you guys, I think I've done this before, but we're going to take it down because I want you guys to see it boot up, how it looks on the screen, so that way nothing funny's there. Going to take off that top left viewer count. Way it ain't in the way. And okay, we're going down. Give it a few seconds for all the fans to stop, and we're going back up. And this switch will boot up. It's going to look frozen, but if you hit enter, nothing can happen. So we're waiting. So kind of watch the lights as the stuff come up there. It gives you an idea of kind of what's going on. So it's decompressing the image while it's off. And this is the iOS. And what iOS does is basically the operating system of the switch. It's the best way to think of it. Notice the time it decompresses, the lights come back on the switch. Now if we look here to flash, this is a C2950, like I said, one of the switches for the lab. That's why I'm lucky I had it deracked. I got it here. Kind of show you guys. The image is a 12.122. I mean, not one, yeah, .12.122. This image is fine for your ICND 1 and CCENT and even your CCNA. The images aren't that big of a difference. The only thing you're going to see as far as images as maybe IP version 6. I don't know if it's supported on here, which we'll see, because I'm not sure if I've ever looked. But that would be the only thing that might not be available on this switch. But you wouldn't be using IP version 6 on a switch anyways, except for maybe a VLAN IP configuration. But to be honest, IP version 6 wasn't talked about much in the ICND 1 for something like that. So as we can see, we're coming up to the start of this. It's done. So it's a C2950. This is the image. Basically, this is the version of the image. And we can confirm that by doing show version. And you can see it all right there. Top of switch. It says 24 port. Is that right? Yeah, it is 24 port. Did I say 24 earlier? I can't remember. Might have said 16 by accident, but it's 24 port switch. Here's the MAC address. Some serial numbers. Model number, and usually the last one is the port number. For example, if it was a 48 port, it would have 48 at the end. It would be a WS-C. C stands for Catalyst. 2950. So, nothing. Show version's pretty common. It's a standard command from there. So, we have 3 modes on a switch, basically the same as a router. We've got the enable, which gives us privilege mode. So user exec is the one before it in. User exec is up. User exec hopefully is. I gotta turn off that domain lookup. But let's do it now actually. Yeah. Oh, maybe I don't have it on here. Don't have it. Alright, so anyways, so we have, let's go back out of it, exit, enter. This is user mode. Kind of notice here, and this is going to be the same for your routers also. We have the greater than sign. If we go enable, or EN for short, it doesn't matter how you do it. Just note that it's enabled. They might ask you the full command. You notice this is considered privilege mode, which is with the pound sign. Then you got configuration mode or configure terminal mode. And you get the config mode. And then if they want to get more detailed, you might have a interface mode for IF. And there will be the modes that they mostly want you to know what to visually look like. And you'll have to know some of them commands because they might have a question. For example, which would be right. This is not a router, but let's say to pretend this is a router. And they might give you something like this, you know, and which mode would be right. And this might be, it might be one in this mode, one like that in that mode, and then one in this mode for IP address. And now I'm saying a router, it wouldn't be in a switch unless it's a VLAN. And you would have to know that this would need to be in the config interface mode. We could make that valid by doing this. Big T interface VLAN, or Big T interface VLAN, sorry, 1 IP address 10.1.1.1. This would be valid. They might have something like this. Which mode would you be in? And they'll show different user modes, and you will have to know that that is in this mode. And for example, I will hit enter. I will try the same thing in this mode just to show you. Let's see, error detected. I can go into config terminal mode, and then the same command also doesn't work. So they would throw a written question like that. Now expect something like that on your ICND 1. So know your modes. Usually if something doesn't work, a lot of times it's because you're in, well, almost every time you're in the incorrect mode for that command, or you typed it incorrectly, or it's wrong altogether. Interface mode basically configures ports and virtual, what I call virtual ports, and serial. In this case, we don't really have serial connections on switches. So your most common commands you want to learn up first when it comes to switches is basically maybe changing the name. Let's say we want to call this the C2950, or let's call it what it is, WS2950 24. And all of a sudden our switch is renamed in the global configuration mode, or some people call it global, but I call it configured terminal mode. But a lot of people call this global configuration mode, and that's probably the proper term. It's global configuration mode. With the hostname command, I can change what this shows as when you log in. So that way, and this is useful when I can quit typing in the wrong thing. When I first come in, I hit enter, all of a sudden I know exactly which switch I'm in. And somebody might call this MDF1, MDF2, IDF1, or something to that extent, to represent where it's maybe located, or the switch type. So you can about name it. There's several things that you can't name it. You can play around and figure out what you can and cannot, but you can pretty much come up with some naming convention that works good. So the other common thing that you'll use, and it works on router and switches also, is password. Wrong mode, like I said, password. Let's see here. Log in. Let's get back out, exit, or end. See if I'm typing it in right. Oh, enable. That's what I'm missing. Enable. Let's do a password if it allows me. A recognizable command. So let's go up a level. Enable password. There we go. And then let's just say we want to make this password. You know what? We'll do a password CCENT. And then we'll end, and then we'll exit, and then look what happens. And when I try to go to enable mode, it's going to prompt me for the password. And what we will do is CCENT is the password, and now we're there. And then if we want to take off that, no enable password, CCENT, and it will remove it. End, exit, and I'll start typing the full command so it helps you guys remember. Enable, and notice no password. Let's say we wanted a password when we first get into the console. So what would we do to that? They will line con 0, log in, no password is set, so password CCENT, log in, and then end, and then let's exit, and let's see if it prompts us for one. And there you go. So time somebody plugs in, before they can do anything, they must type in a password, CCENT, and now we're back in business. I put EM instead of EN. So here's the thing you don't want to do, really and truly. When you do an enable password, and I'm going to go back over to line console 0, and we're going to put no password, no login, and an end. So I'm out of there. But okay, if you're going into enable, this is for your privilege mode, enable secret instead of password. Password is unencrypted, where secret is encrypted. For example, secret, CCENT, and show run, which shows the running configuration. Look here, this is my password, and notice that it is actually encrypted or hashed, probably the more correct term. So if I go over back to config T, no enable secret, and then let's put enable password CCENT and show run. I want you to see the difference here. Look here. Shows it in clear text, my password. You could get a question like that on the ICND. What is the problem, or what is considered more secure and enable secrets more secure? Or maybe they give you an example and you can look at the configuration or running configuration of a switch, and they might have a few questions, and one of them would say what could be done better, and you could point, or security, what is security vulnerabilities, and one of them would be password being password instead of secret, so it makes it unencrypted or basically unhashed to where it's in plain text also. And as we can see, we're gonna take that off. So no, or config T, global configuration mode, no enable secret, and show run, and it shouldn't be there anymore. Nope, it's still there. Oh, I did secret. It's supposed to be no enable password. There we go. Show run. Now we shouldn't have anything in there, and now we don't. Now, the show run command, which you see me using, is probably one of the biggest troubleshooting commands that you have. And what it is show run is short for show running config. Doesn't matter how you type it in if you do just show run or show running config. But it will show me everything that's been configured basically on the router. Or not the router, I'm sorry, switch in this case. See, we can see the hostname command was put in. Some of this comes basically like a default. Spanning tree is on. And then we have some interfaces, but no configuration. This is normal. They're going to show you the interfaces because this determines how many you got. We got 24. Notice we have a VLAN configured with an IP address, which we did earlier. Here's our line console. It's showing us that we got a console line, VTY line for telnetting or SSH. And telnetting is not a safe or secure practice. SSH is definitely more secure. You could have a question like that. SSH is the preferred way to remote in versus telnet, because it actually hashes or encrypts the data going across the line, where telnet, it shows as plain text and can be basically stolen if somebody can get to your lines or monitor the lines that you're connecting through. So show run is a command that you want to get very familiar with the switch. The other one would be for troubleshooting is show interface brief, or excuse me, show IP interface brief. And I like this because it's super neat. It shows me that VLAN does have an IP address. It shows me that the status is up and then the protocol is down. We'll talk about that in a minute. And I can see what's up and what is down. and we have nothing technically up at this point. You got show MAC address. You got show MAC address table. That's a big one. As you can see, the MAC address is here. And we'll talk about a few things into a switch also, especially as we progress more. One thing that you really need to remember is that layer 2 switch, which is the switch. When they say a switch in the CCENT, it's going to reference to a layer 2, is going to be based on MAC addresses. That's just how the switch works. It has a MAC address table, and it determines how and where to forward the traffic to. And you'll learn about the ARP and broadcast, which is used across the switch. So it's, like I said, a lot of focus across this. And the MAC address has a broadcast address, and an IP has a broadcast address, and you need to know both of those for sure too. So okay, we're looking at the switch here with this camera. So I'm going to go ahead, we're going to take a look. We're just going to, let's minus down some here. Let's get some of that a little bit clearer. Like I said, I was just showing a few commands, more popular commands that you will definitely be getting familiar with. The troubleshooting commands go a long ways. So what we're going to do, we're going to plug into this port 1 right here. Let's kind of watch what lights up on the switch and what comes up on the screen at the same time. So notice the color is like a reddish or amber color. We have a changed state to up on the Fast Ethernet 1. We have the interface, which is changed state to up, and then we have a line protocol on the interface. And first it says down here, but it goes to up. And then notice here shortly, once the switch does a little bit of talking to my PC, it turns green, and now the VLAN interface state comes up on the line protocol. Now if we remember correctly, it was up over here in the protocol, and you will learn a lot about VLANs throughout this course. They're not complicated, but it's something, and we'll talk a little bit about it. So show IP interface brief, as I said earlier, it's a popular command. Now we can see on Fast Ethernet 0, unassigned set up. And what we're going to do is IP config. This is on my PC here. I'm going to scroll up and see. I think I manually put in an IP address. And there we go. Let's see, do I have one? Yes, I did. Now here's the thing, is that your switch, you will have to, if you're connected only to a switch, you will have to manually configure your IP address to be into the, which you will see here shortly. I manually configured my IP address, and the purpose behind this is so the following basically. It's because the switch operates at layer 2. You can be assigned a MAC, or you can't be assigned an IP address, and the switch doesn't really use IP addresses except for the VLAN. So you can assign an IP address to VLAN. So let's ping, let's see if we can ping that VLAN. And in this case we can. Now I've probably timed out because of ARP. And your computer also holds an ARP table. As you can see, there's one here, but here is another one for me. And this should be the interface that I'm on, is it? Doesn't look like it actually. Here we go. This is the MAC address table for this PC, or the ARP table. And as you can see, they take MAC addresses and they basically look at IP addresses. Now notice here we have a physical address of all F's in hexadecimal. That is a broadcast address. And this right here, the 10.1.1.255 for that network is a broadcast address. So it's mapped a broadcast address of the physical address, which is known as the MAC address, and the broadcast address for our IP network that we're considered to be under, or we kind of assigned ourselves here. So now, can the switch, you think, ping my PC here? You notice that it can. You can run a ping off a switch also. And then let's do a show MAC address table. And let's see, our IP address should be in there, and it should be this right here. So let's look at our MAC address off of here. And we are IP config all. IP config all. This is my PC. And DOS prompt. Let's go all the way up. Here we go. Let's see what my MAC address is. It's 6C62, 6C62, 626D, or 6D57, 6D57, A523. So you can see that my MAC address, and it even says the port that I'm on. This is the MAC address of my PC, and it identifies which port I'm plugged into. So now the switch is learned about my MAC address through a broadcast, basically, or through it being sent information. So show, or better yet, let's see if we can remove MAC or delete MAC or clear MAC. Let's see if that's it. Address table. Okay, so we're going to clear the MAC address up. It says incomplete, so I'm missing something else. Dynamic, which is how it learned mine, IP. Now let's do a show MAC address table right quick. Up. Address table. Now it's learned mine already, so we were a little too slow. Up. And it's learning it too fast. So let's see, I'm going to unplug it right quick and show you kind of how that works. So we're going to unplug ours a little bit. We're going to see it down here. And we're going to clear MAC address table dynamic. And we're going to show, you see it's not in there currently. Now what you need to understand is once you've sent something through the switch, it starts out as a broadcast, and then the switch makes a table of what port your MAC address is on, so it doesn't have to broadcast through all the ports again. So the first time you hook something up, it will do a broadcast. So we're hooked up. Now look, we just now learned the MAC address. So now it knows what port to send the packets or the information from another PC. So it's basically, I won't say routing, but switching based on MAC addresses in the table. So at first it goes through all ports, kind of like a hub. It goes all the way, it broadcasts through all the ports for whatever it's looking for. If it reaches the switch, for example, I guess the best way to say is if it reaches the switch and it says, hey, Wade's PC, won't say Wade's PC, but I'm just giving a reference. Hey, 6C62.6557 or 6D57.8223's MAC address is looking for MAC address maybe 6C62.6D57A663. And it's going to send it through all ports but the port that it come through on. So it basically, if it was doing that, mine would come out of this port to the switch. If the switch did not have the MAC address that I was trying to communicate with or send information to, it would send it out of all ports except for the port that it received it on. Basically floods the ports, and then whoever has the MAC address will reply, and then the switch will, then when it replies back to basically my PC or through the switch then will take its MAC address when it passes through it and set it to the port that it received it on. So basically when you first plug something in, it's going to flood all the ports for communication, unless it communicates to the switch or to something near, or basically your first packet you send to the switch, until you send it, the switch has no idea what's on that port. But once you send the first packet and it goes through that switch takes the MAC address out of the packet and it sets it into the table. Then it creates a table, and it'll create a table for every port if you have a device hooked to every port. And what it does, it keeps from putting information into all the ports like it does a hub, and it switches it accordingly, which is more secure in a way, and it also gives you a lot more bandwidth because you're not going through all the ports, so it kind of keeps traffic and your collision down. You have there's what they call a broadcast domain and a collision domain, and we'll go over that probably very soon, if not in the next video or two. And that is definitely something that you will need to know. As in the ICND 1, you will see something based on collision domains and broadcast domains as a question, if not a few. So okay, there's the MAC address table. Remember, this is a lot of problems you can figure out sometimes on the MAC address table itself. So okay, let's show interface, or IP interface, rather yet. And let's look at something else on here. So a lot of this is going to be talking about how to troubleshoot, because if you troubleshoot, it will give you a lot of knowledge, or you understand how everything works. So okay, we look at this. We have a up status on VLAN 1, up status on the port or the physical, and then an up on the protocol. Fast Ethernet 1, we have an up on the status of the port and an up on the protocol. So what I want you to understand is that this is basically the physical link, and this is layer 2. So layer 1 and then layer 2. So if you hear up, that means you're up on layer 1 and you're up on layer 2. And if you ever hear up, down, that means you're up on layer 1 and you're down on layer 2, which means your cable's probably fine, everything's plugged up well, information's coming through, or somewhat coming through, but your protocol is down, meaning that it can't fully communicate. So an example would be, it's not, basically when you look at the OSI model, and if you haven't, you want to go back and reference, you hear what they call physical, and then layer 2, which I call it basically like your MAC address is one of your biggest ones in layer 2, and your layer 2 protocols. It's not, when you hear physical, it's like it says it's physical, but don't get so stuck on it. It's not always the cable. So it might not always be the cable. Basically, I can have this cable in. We know it's working right now, for example. And this could be the same way on the PC, just a different method. So I'm just going to go on here and put in interface fast Ethernet 00, you know what I'm on, no 1. And then I'm going to do shut. Alright, notice that the light is off now. And notice what this says now. I'm going to end, show IP interface brief. Now notice fast Ethernet 01 is now administratively down and then down. So technically this would be what, a layer 1 problem. Now luckily we can tell that this is administratively down, which means it's down by the switch. We've forced it down. And it's not the cable. The cable is actually fine. It's the port is shut off, but it's still considered a layer 1. It's still physical. So don't get confused and get caught up thinking that it's only a cable issue, as it can be just the port is shut down. We're going to bring that back up, and you're going to see it light back up now. So you got shut and no shut. Obviously shutdown turns the port off, and then no shut turns it back on. So what you will need to know is on switches, by default Cisco has the ports on no shut, but on a router by default your ports are shut down. You have to go in and do a no shut command. Or switches, they're all up. But a good practice as a switch and a network administrator, unless the switch is near you at all times, is to go in after you have set up a network and shut down pretty much all of your ports that are not being used, to keep somebody from just plugging in as easily into the network. Because if they unplug somebody's and then they try to plug in, then somebody's going to be yelling, so you're going to get a heads up. But if you leave them all up, somebody can plug in, and unless you are got a monitoring or paying attention basically, or physically in the switch remotely, then you will not know. So it's good practice, in my opinion, to shut down ports once your network is set up. You know how many ports are being used, to shut down the ports. That way, if somebody goes to plug it in, you will be the first to know by maybe an IT person there, or a field IT person, that hey, they're plugging more in, and you will have to physically go in there and turn them on. And then that will help remind you if you need any kind of port security, which we will cover later on. I will say the ICND 1 mostly is a lot on the default commands and a few of your other commands, so you really want to know what your defaults are, and so on from there. But do know that that is layer 1, and this is considered layer 2. So if we do a show interface, or IP rather, interface brief, now we are back on the up. Now VLANs, which is a little bit different, here you would think it's layer 1, and it still technically is layer 1, even though VLAN is a virtual local area network. So let's say VLAN, which is the interface, you still use the interface command, which is a little bit weird to some people at first, but interface VLAN 1, I can actually shut it down like a layer 1, and it will go down, even though it's virtual, and people still consider this a layer 1 down basically, but it's a virtual port, or a virtual LAN that is assigned to a port. But as you notice, it doesn't take port 1 down, even though VLAN 1, if we look, has fast Ethernet 01 in that VLAN. And as you notice, VLAN 1 is the default VLAN. That could be a question, but you'll be familiar with that by that time. VLAN 1 is the default VLAN for Cisco, and pretty much default VLAN for most vendors that I've ever ran into, or all vendors that I've ran into so far. So alright, let's go back into that interface VLAN 1. Now remember, VLAN is actually virtual, but you still have to go into it like an interface because it's assigned to interfaces, or can be assigned to interfaces. Interface VLAN 1, which is virtual, and we'll no shut, and then I'll bring it back up. What I want you to see is, let's see if I can get one in there quick enough. I shouldn't be able to ping it while it's down. So let's see if we can take that back down. Let's shut. Let's see. I want to see the line go down. There it goes. Now watch what happens. Now I'm not able to ping the switch because there's no way for me to ping it outside of going through a MAC address. So the only form of pinging a switch would be setting, or pinging it via IP, is setting up an IP address to the switch, and then we will no shut, or no shutdown. port, and it should come back up. Once it comes back up, I can ping again, as you can see. Now remember, this is my PC here, and this over here is my switch, even though they're the same color. This is the switch. So we're going to end. And remember, this is configure interface mode. User mode, or user exec mode. Enable, I spelled it wrong. Wait for that to finish. Enable mode, which is privilege mode. I call it enable mode, but it's really, the technical term would be privilege mode on a test or exam. Global configuration mode, which is global terminal. And then you've got interface. Got interface mode. And the one you won't have on here is router. And you do have a router mode, but there really wasn't much asked. Them are the main modes that you want to know to carry over to the router. The router has an extra mode called the router mode. But you want to know your user exec mode, privilege, global, which is your config terminal, your interface, and then you got the one on the router mode on the router itself. Switch won't have the router mode, so don't think they'll throw a trick question on that, but always be careful. There was can be a troubleshooting scenario, and you really got to pay attention to the questions, because they might have a switch and then connected to the router, and then a switch 1 connected to a router 1, and then a switch 2 connected to a router 2. And you need to make sure when you're troubleshooting or answering the questions that you're looking at which one you're in, because it's easy to get confused. They might have the exact same questions to each one, and it's easy to get confused and put the wrong one, even though you knew what it was, because you didn't catch that it was a router 1 instead of a switch 1, or etc. from there. So as we can see, let's see, I said I was going to look to see if this one had IP version 6 on it, didn't I? So let's do a big T interface, or interface VLAN 1 IP, and that's probably not going to tell me, but this would, and it looks like not, and I didn't think it would, and that's because of the version here. So the 2950 does not support IP version 6, but to be honest, you're not going to be doing anything with IP version 6 for the CCNA in a switch. You're going to be doing them in the router, and they will have the IP version 6. So you want to make sure when you're buying your lab equipment that your router has a 15 dot whatever version, and your switches at least have a 12 dot or higher. And in this case, this is the highest image, I believe. Well, there's a higher EA for the 2950. And you can load updated images with license with Cisco. And we will talk about loading images via TFTP. So what we'll talk about before we end this is we will go over VLAN right quick. So VLAN, guys, and we'll switch ports as we're talking about it. See if there's any difference. So a VLAN, guys, is basically, like I said, it's a virtual local area network. Now the purpose of a VLAN is that we can take, for example, we have 24 ports here, and I've got them, if you look, there's a section of 8 here, section of 8 here, and then a section of 8 here. If I wanted to with VLANs, I could split this switch to look like 3 different switches with 8 ports. That's a good idea how to think of VLANs. VLANs are like configuring ports I can take 3 ports and make it a switch itself. I can take then 10 ports, make it into a VLAN 2, and it'd be like a separate switch. And then I can take the remainder of the ports, put it in a VLAN 3, and it'll be a separate switch. They will not see each other. They will not communicate with each other because they're going to think logically, physically they're on the same switch, but logically they're thinking that they're on different switches because they don't see each other. It basically divides the ports up. A lot of people use VLANs for security purposes. Maybe they put 8 in the accounting, 8 in the shipping, and then let's say like 2 or 3 in the HR, and then the remainder might be management or something to that extent. So VLANs become, because you wouldn't want your HR people being able to share stuff with, or sharing stuff maybe with your accounting, and vice versa, your accounting to share stuff with the HR, or your shipping to be sharing stuff with HR or something to that extent. So you would have VLANs set up to help prevent that possibly, to keep them under their own network, so you don't got to be worrying about what they're sharing, and it stays to their department from there. So I mean, that would be one good reason why you would create VLANs on a switch. VLANs, of course, is for other benefits also, which you'll learn down the line. Of course, we assign an IP address to a VLAN, and it will let us know if we have connectivity. For example, on this, I'm able to ping VLAN 1 because it has an IP address. So it allows me to actually ping the switch to make sure that my switch is up and doing fine, versus not being able to, and then I'd have to go a little bit different route to check it. But VLANs basically takes and separates it. So if we look, we got that up. You can see here, we got the Fast Ethernet 02, show IP interface brief. Notice that interface 2 is up. Now it says the IP address is unsigned, but let's say I go onto interface 2. Zero 2, and I'm going to try to assign it an IP address. It's not going to take, as you can see. I cannot give it an IP address because it doesn't support an IP address. It's a layer 2 switch. And if it wasn't a layer 2 switch, basically I would be able to do IP routing, and you notice that I can't, because I don't have the option. But on a layer 3 switch you could do the command IP routing, and it would allow you to turn the switch into like a layer 3 switch that uses, or a capability to use IP and route some. But in this case, layer 2 switch don't have the ability. Now once again, in the CCNA and your ICND 1 for your CCENT, you will not, when they use the term switch, it will be strictly layer 2. So guys, that does it for this video, for the basics of a switch and some of the basic commands. There will be several videos covering the switches. It's one of the larger portions into your CCENT. I would say your routers and your switches and all the questions around it is going to be based probably about 70% of the exam to 80%. Basically everything revolves around them and how well you know them. But from my experience of the ICND 1, the switch is probably more focused than the router. In the ICND 2, it seems to be flip-flopped. It's a lot more on the routers than it is the switch. So in your ICND 1, we will be looking at the switch a lot more. We will be looking at routers because they provide the layer 3, and all networks usually going to have a router at some point in the network of it, usually one at the minimum. And so we'll look at those combined with switches, but we will be focusing a lot on the switches because through my experience, the switch was one of the keys to doing well in the ICND 1, I actually expected more of the routers, but I was wrong. It was a lot more on the switches, which was fine with me. But it was really a ton on the switches, and a lot of that stuff carries over to routers, as you will see in later videos. So if you get used to the command line and the switch, you're going to be familiar with probably 50% or more of the router's command line right off the bat. And the only things you'll have to learn to set a network up would be your routing commands, basically, in the router, because you will have seen everything else command line, and it would be familiar to you from looking at a switch interface. So remember, guys, if you are connecting to a switch, and I probably should have showed this, if you are connecting to a switch, do not forget if you set up a VLAN, for example, let's say you got yours and you're going to run this lab, you do interface VLAN 1, which is your default VLAN. And remember IP address 10.1.1. You can follow this one, 10.1.1.1, 255.255.255.0. That's our subnet mask. We hit enter. That gives it an IP address, and then we're going to hit end. And then if you want to make sure that your VLAN is created and it's active and in the port supports it, you would look at something like this. As you can see here. Now I should be able to ping it, as you can see that I can. But remember that you must, because it is a layer 2, so it will not help you with an IP address, it will not assign you an IP address. You must go in and manually configure an IP address, but make sure that your IP address is in the same subnet. For example, we have a 255, 255, 255, so these first 3 all must be the same as the VLAN's IP address. This will be the only host portion that will be different. It can't be the same as the switch. So I used a 25, and make sure your subnet mask is as follows. Now once you do that, you will be able to ping your switch if you're trying to set it up to where you can ping it. And it won't be too bad. Now let's say by default your port should be in the VLAN 1, but if it's not, I will show you the command right quick if you want to do that. So we will go into the global configuration mode, interface fast Ethernet 01 in this case. Well, in our case we're actually connected to 2, but we'll do it on fast Ethernet 1. You're going to do switch port access VLAN 1, enter, and the switch port mode, and you might have to do this one first, access, enter, and then you should be able to do IP interface this, and you should be in the, well, not that, wrong one, show VLAN, sorry. And then you should see your interface into the correct VLAN. For example, I will show you, I will move this one right quick actually before I end this video. So there we will be switch port access VLAN 2 and show VLAN. Now you can see that my fast Ethernet is moved. It's not in VLAN 1 anymore. It's went to VLAN 2. So the command that I just showed you earlier, that 01. Now you have to check if you got a different port, a different switch. Remember, you have to check to see how your Ethernet ports are labeled. And then I would do switch port access VLAN 1 end. And we will talk more about what each of these kind of mean. Basically, you have an access or a trunk port, but we'll talk later on about that as we get deeper into there. And now you can see that my, wrong command once again actually, show VLAN. Now you can see that fast Ethernet 1 is actually back to VLAN 1. So the question is, actually, I want y'all to kind of see how VLANs work. Actually, I'm in 2, so let's go to config T, interface, fast Ethernet 02, switch port, access, VLAN 2, and ping 10.1.1.25. Notice, which is coming back up, it's going to take it a minute anyways to switch VLANs. Should have fast Ethernet under VLAN 2, and I do. And the question is, show interface brief. There it goes. Okay, now it's blue. So now can I ping 10.1.1.25, and you notice that I can at this point. Now can I ping the entire time I've been able to ping this? And notice now that I cannot ping 10.1.1.1. We'll give it a few minutes just to make sure. And it would have started pinging by now. Now this is what VLANs do. This thinks it's a separate switch than port 1 currently. Do that again. And you can see, I'll actually time that out. I will ping T, which is continuous off of my PC here. And we will go back. Interface fast Ethernet 02, switch port access VLAN 1 end. And now watch what happens. It's going back to amber. Notice it's amber when I switch to VLAN, so it's having to converge back over to VLAN 1. And once everything gets going, our ping should start working. So still waiting. It takes it a minute to go green. Newer switches are a little bit quicker to converge, and we're going to give it a little bit more, and then we should see the ping start succeeding here shortly. It still might take it a minute to pick up on it, but let's make sure that that up on here, over here, it is up. Should eventually get some kind of ping. Not sure if it'll be quick enough for this video or not, but eventually it will allow me back to being capable of pinging. There it goes. So you see that did take a while. Now newer switches, it doesn't take as long. So remember when you're doing these VLANs to give it a minute. But now I can ping, now that I put it back into VLAN 1, because it sees this IP address, where on VLAN 2 it's not able to see VLAN 1 because it thinks it's a separate switch. So that's an example of how VLANs work. We'll do better examples later on in later videos as it advances through GNS3, where y'all can see a little bit better than just a physical switch, but you physically kind of seen how this worked. So guys, that does it for this video. I hope this video has been some benefit or has helped you guys out understanding the interface of a switch, kind of how a switch works, how VLANs work a little bit introduction wise, some of the basic commands that you will use in a switch. I got to show you commands how you can do your VLANs to be able to ping from your PC to your switch if you're plugged in. From there, and the basic function of how a switch kind of works. Remember, a switch is a layer 2 device on the OSI model, and a switch builds a MAC address table, and that's how it determines. That's how it determines how it switches to direct traffic, where the traffic to go instead of broadcasting it through. Back in the day, they had hubs. Hubs went out of every port every time something was sent. Switch does not. Once it learns the MAC address, it only goes to the port it finds the MAC address or has the MAC address table to keep from having collisions and it creates separate collision domains, which we will talk more about in a future lecture. Thank you guys for watching. If you enjoyed the video or if you found this useful, please remember to subscribe and follow, whichever. Like the video if you enjoyed it. Let me know what you think. You can comment below. If there's anything you want to see in particular, let me know. This video should help you in the future videos towards getting your CCENT certification along with Net Plus related certification also. Thank you guys for watching. Until next time, guys. See ya. Peace. Take care.